So, sig figs and calculations. When we do a calculation, the calculator will often give us a ridiculous number of digits. Because like if you take the number 10 and you divide it into 3 equal parts, it doesn't divide evenly, right? You end up with 3.33333333333333. We don't use fractions, we use decimals. And so how many 3's should we write down? The rules of significant figures help us to know how many digits we should write down. These rules tend to be confusing for students. If you can keep at it, keep asking questions until that light bulb, and I can actually see the light go on in your eyes when you get it. It's awesome. I love that. If you keep asking questions until it makes sense, then it's easy. Until then, it's not. But the alternative is differential calculus. And I don't remember that from college, so we're not going to do that. So we use rules so that when we do a calculation, how we report the result reflects the precision of the number. So sometimes we have multiple steps. We're going to add some things, and then we're multiply, and we're going to divide, and do all these different things. We want to round only the final answer. Do not round off between steps. Every time you round off, you can possibly introduce a little bit of error, and if that number is going on and being used again in another calculation, those errors can sometimes build up and be significant. So we're going to round off at the end of our calculation. So we're going to look at two types of operations. Multiplication and division are essentially opposites of each other. And so they use the same rule. So when we multiply or divide numbers, we're going to look at the number of significant figures. So the answer will have the same number of significant figures as the factor with the fewest sig figs. So we're looking at number of significant figures. So in this example, 5.02 times 89.665 times 0.10, your calculator is going to give you something like that. We need to decide where should that be rounded off. We're going to look at number of significant figures in each of the things that we multiplied. So we look at this first number, 5.02. How many sig figs? 3. The trapped 0 is counted. How many sig figs in this one? 5. That one should be easy, no zeros. How about this one? 2. The leading 0 doesn't count. The trailing 0 does because there's a decimal point. So that's the hard part. This is the easy part. Which is smaller, 3, 5, or 2? 2. Okay, so we're going to round our answer and just keep 2 digits. So we're going to keep the 4 and we're going to keep the 5. A notation that we often use is we underline the last significant figure. That's the one that has uncertainty in it. And then we have to round that off. So we're going to look at the next digit to decide, is this closer to 46 or to 45? Well, this is obviously closer to 45, and so we're going to report the answer as 45. This implies that there's uncertainty in the ones place and that that answer is between 44 and 46. If we wrote this whole thing out, that would imply that the uncertainty is way over here, and that's not correct. Dividing, it's the same rule. So this number divided by that number. Well, which one has the fewer number of significant figures? The 6.10. So this one has 3. This one has 4. Trailing 0 at the decimal point. So 3 is smaller, so this needs to be rounded off to 3 significant figures. There really should be a 0 in front of this. We should always put a 0 in front of the decimal point just to call attention to it. Decimal point is small and can be overlooked. So that leading 0 doesn't count, but the 9, the 6, and the 5. So we count 1, 2, 3. Here's our third digit. That's our last significant figure. When we round, we just look at the next digit. You don't completely ignore the rest of them. They're garbage. We look at the first one we're getting rid of. It's a 9. That means we need to round this up. So we're going to say that the answer here is 0.96 6, because it's closer to 0.966 than it is to 0.965. Any questions? So here's a slide about rounding. You're just going to look the first digit that you're getting rid of. Oh, I got to fix this slide. Your book talks about the last digit, and if that makes sense to you, great. It doesn't make any sense to me. Look at the first digit that's being dropped. If it's less than 5, round down. If it's 5 or greater, round up. We're not going to do an odd even thing. If we're rounding these to 2 digits, 2.33 is going to round to 2.3. 2.37 is closer to 2.4. Here's something that we sometimes have problems with. What if we have 23,700 and we need to keep 2 significant figures? I need to keep the 2 and the 3, and I need to round the 3 up to a 4 because of the 7. Is it 24? No, because 23,700, is that anywhere close to 24? No, it's huge compared to 24. Here, we're rounding off. It'd be good to refresh your memory on names of decimal places. This is the ones place, the tens, the hundreds, and the thousands. We're ones, tens, hundreds. Yeah, I'm sorry. I had a brain fart. My brain just freaked out on me. This is the thousands place. Okay. Apparently, I need a refresher course on that, too. We're rounding to the nearest 1,000, right? So this is going to be 24,000. That is close to 23,700. I see students do dumb things like this very frequently. Okay? That doesn't mean you're dumb. Everybody does dumb stuff, right? And we say, oh man, that was dumb. Let's try not to do that again. So here I'm just pointing out a dumb thing that students do so that hopefully we can do it less. Okay? It'll still happen. It's okay. So the idea here is if you're rounding anywhere to the left of the ones place, anything higher than the ones place, be careful. Some of you can round this to 24,000, you're good. Others of you are going to get into trouble. If you're a person that gets into trouble, the best thing is to put the number in scientific notation. So we take that 23,700 and we write 2 point, and I want to keep this place. It's going to have to round up, so I'll make it a 4 times 10 to the, and the decimal point was here. It wasn't written, but it was understood. 1, 2, 3, 4 places. So then the exponent is 4. That's a big number. It's a positive exponent. Okay? So let's do some examples. You should bring your calculator every day, and you should pull it out when we do calculations and try it yourself. I make mistakes, and a lot of students find it very enjoyable to catch me in the mistakes. And yeah, it bugs me when I make a mistake, but I want to know. Okay, so if I screw up a calculation, please let me know. So we're going to do something like this. Just punch it through on your calculator. So 1.10 times 0.512, oops, screwed up already, times 1.301 times 0.005 divided by 3.4 equals. Always a good idea to write down what your calculator tells you. So my calculator is giving me all of this nonsense. Anybody else have their calculator showing them that? You just nod your head. Okay. So that's way too many digits. The rules of sig fig say that we've got multiplying and dividing, so we're going to look for the number with the fewest significant figures. Do you have to go through and identify all of them? No, you just have to figure out the one with the fewest. What's the one with the fewest? What about this one? 0.005. How many sig figs in that? just one, because leading zeros don't count. This one has one significant figure, so then my answer should have one significant figure. Leading zeros don't count, so the first digit is the 1. And then if I'm going to round that, I'm going to look at the next place. It's a 0. Well, that's less than 5. So I'm going to say this is 0.001. Any questions? You've got to get comfortable counting the sig figs first, and then you can do the calculations. Let's do this one. Let's predict how many sig figs should the answer have. 3. This number has 3 sig figs. This has more than 3, and that has 4, which is also more than 3. So then we'll keep that in our mind. 3 sig figs. Do the calculation. 4.562 times 3.99870 divided by 89.5. This can save you writing down lots of stuff. So we determined already that it should have 3 sig figs. So I'm going to write down 0. That doesn't count as a sig fig. 2, 0, 3. There's my third sig fig. Now write down 2 more digits. Don't worry about rounding or anything. Just write down the next 2 digits. I've got an 8 and a 2 after that. There's more. There's a 2 and a 0 and a 0 and a 4. If you want to write them all down, you can, but I don't find that particularly fun. Write it down like this, keeping 2 extra digits, and now we can look, do I need to round this up or down? I need to round it up because 8 makes us closer to 0.204. So there's my rounded answer. Here's the rounded answer for that one. Yes?
Do you prefer us to write it like that or in scientific notation?
That's an excellent question. In my opinion, scientific notation is never wrong unless it's asking you to convert to decimal notation. So if you want to put it in scientific notation, I am absolutely fine with that anytime. And so this number could be written in scientific notation. It would be 1 times 10 to the minus 3. You could write this one in scientific notation, 2.04 times 10 to the minus 1. Absolutely fine. Kind of my rule of thumb is if there's more than 3 zeros either side, I have a hard time seeing it immediately, then I think it's good to put it in scientific notation. You know, if it's 0.0000004 and you have to get your finger out and count, put it in scientific notation. Any other questions? So multiplication and division, you're looking for the number being multiplied or divided that has the fewest number of sig figs. You round the answer to that number of sig figs. Adding and subtracting is a different rule. It's a different type of a process. So adding and subtracting are also sort of opposites of each other. Here we're going for the fewest number of decimal places, not fewest number of significant figures, fewest number of decimal places. This is a definition that doesn't work very well in some situations, but mostly it does, and it's easier to remember, so we're going to go for it. So to understand how this works, let's look at something that's stacked with the decimal points all lined up as if we were going to do this without a calculator. I don't recommend that because, you know, your brain does these funny little tricks on you and you get the answer wrong. So go ahead and do it on your calculator, 5.74. This isn't math class where they want you to do all that stuff in your head. Plus 0.823 plus 2.651. Calculator shows me 9.214. So one way of explaining this is let's look at these numbers and identify which is the uncertain digit. 5.74, which one's uncertain? The 4. How about 0.823? The 3. And 2.651? The 1. It's the last digit. That's the uncertain one. When I'm adding these together, here I have a 3 that I'm not sure about and a 1 that I'm not sure about. Can I be certain about the 4? No. That is uncertain. So I'm going to underline that because that's iffy. Here I've got a 4 that has some uncertainty. Maybe it's 5, maybe it's 3, we don't know. I'm certain about the 2 and about the 5. When that adds up to 11, am I certain about the 1? No. So there's uncertainty here. Over here, certain 7, 8, 6, those add up. I can be confident in that too. It's actually a part of a 12, but you get the idea, right? So there's uncertainty in the 1 and the 4, in the hundredths and thousandths place. We only want one uncertain digit. Yes?
Would the 2 also be uncertain because you get 11 from the previous digit?
That's a good question. Would the 2 also be uncertain because you get 11 from the previous? Well, usually the uncertainty is 1 in either direction, right? And so if it was 1 less, it'd be 10, and we'd still get the 1. If it was 1 more, we'd still get the 10. So that was a good question. So we want to keep the first uncertain digit, so we're going to call this 9.21, because we want one estimated digit. So that's one way to think about it. We can also think about it by counting decimal places. Decimal places generally refers to how many digits after the decimal point, right? So how many decimal places does 5.74 have? It's got 2, right? 2 decimal places. And how about 0.823? 3. And 2.651? 3. So 2 is the fewest number of decimal places. So then I'm going to round this answer to 2 decimal places. Question?
So if that 4 had been a 5, then it would be 9.22?
Yeah, if this 4 was a 5, because maybe this was a 4, then you'd have to round up, but there's still uncertainty in that last digit. Okay? The other way to think about this, let's look at this subtracting one. Let's go ahead and subtract 4.8 minus 3.965. So the calculator says 0.835. So look at this stacked up problem from left to right. Well, let's first identify the uncertain digits. 4.8, which has uncertainty, the 4 or the 8? The 8. And in 3.965? The 5. Okay, so as we go across, which is the first column that has an uncertain digit in it? It's this column with the 8 and the 9, right? We want to keep the first column that has an uncertain digit. So I'm going to draw a vertical line after, oops, sorry, I'm having problems here. After that. The rest of it is going to get cut off because we only want one place that has uncertainty, the first one. So that tells me I'm going to keep this first decimal place and I'm going to get rid of the rest. I have to look at them to decide, do I round up or do I round down? Here I'm going to round down and it's 0.8. Okay? The other ways of thinking about it also work. You can count decimal places, 1 decimal place, 3 decimal places, answer should have 1. And you can do the stacking thing and see that, oh yeah, it's this one. Different ways of thinking about it. Use the one that makes sense to you. Any questions? You can end up with a different number of significant figures when you're adding and subtracting. So let's do this one, 28.02 minus 27.99. So just do it on your calculator first. The nice thing about adding and subtracting is it rarely gives you a whole bunch of garbage. It's usually going to give you a reasonable number of things, of digits. So when I do that math, I get 0.03 is what my calculator says. Sometimes we have to put zeros on the end. Your calculator does not know anything about sig figs. So this number has how many decimal places? 2. And this one has 2 decimal places, so my answer should have 2. And it does. 2 decimal places. This number has 4 sig figs. This has 4 sig figs. How many sig figs does this one have? 1. Leading zeros don't count. I went from 4 down to 1. It's okay. It happens with adding and subtracting.
It only happens with adding.
It only happens with adding and subtracting. You can end up with a number with fewer sig figs or more sig figs than any of the digits you're adding and subtracting. That's not going to happen in multiplying and dividing. You're going to have, it's always going to be the same number as the smallest. Okay, so here's some adding and subtracting problems. On your calculator, just enter this. Don't worry about doing individual steps and writing stuff down. Just punch it through. Your calculator will understand. 2.18 plus 5.621 plus 1.5870 minus 1.8. So 7.588. Your calculator giving you that?
Yeah.
Okay. There's so many opportunities to screw up when you put something into your calculator. So if you really care if it's correct or not, do it twice, because if it was a random error, it probably won't happen again. If you get 2 different answers, then go for best 2 out of 3. So how many decimal places should this result have? 1. We're looking for the number with the fewest decimal places. This one has 2, 3, 4, and 1. So I need to round this to 1 decimal place. This is the 5. And so I'm going to say this is 7.6. Any questions? That last one, 7.876 minus 0.56 plus 123.792 equals 131.108. If I do it wrong, yell at me. How many decimal places should have 2? This one's got 3, 2, and 3. So I need to have 2 decimal places. That's the second decimal place where the 0 is. And so I'm going to round that. 131.11. Questions? Yes?
So this might be kind of stupid. If the first one were to say that the last number is 1.80, then you have 3 significant figures, but since you're adding and subtracting, it's only,
The decimal places.
or well, like, okay, so when it says perform the correct number of significant figures, but you're adding and subtracting, do you still go by the number of decimal places?
Yes. Yeah, so it says perform the calculations to the correct number of significant figures. That means in your result, follow the rules for sig figs. The rule for adding and subtracting is look at the number of decimal places. Yeah. Mm-hmm.
I was confused. I thought that we were round off because of the 8 instead of 5.
So we've got 1.08. We're keeping this 0 place, but we have to round it up to a 1 because the 8 is 5 or greater. Was that your question? That's okay. Anybody else? So when we have both, thankfully this doesn't come up much in 3A except on the worksheet we're doing tomorrow. It'll be all over the place, so we'll get practice on this. Do the steps in parentheses first. Figure out how many sig figs are in that intermediate answer. Don't round it. Just look at the sig figs. Then do the remaining steps and round the final answer. So I'm going to do these kind of quick. You can watch them slow again on YouTube, and we're going to practice this in lab tomorrow. So perform each calculation to the correct number of significant figures. I recommend just doing the calculation, writing down the mess that your calculator gives you, and then go back and look at what's happening. So 3.897, well, you know what? I just gave you rules and now I'm not following them. That's not cool. Let's do what the rules say. Parentheses first. So 782.3 minus 451.88 equals. I'm going to write this down, 330.42. I'm going to mark on that number the last significant figure, the uncertain one. I'm not going to round it off, though. How many? Well, I've got subtracting there. Am I counting sig figs or decimal places? Decimal places. So this has 1 decimal place. This has 2. So this result would have 1 decimal place. That's the 4. If I was done, I'd round it off, but I'm not done yet. I'm going to leave this number, this whole thing, in my calculator and multiply it by that. Times 3.897 equals, and so I'm getting this big mass, 1287.64674. Here I have 2 numbers that I'm multiplying. How many sig figs does this number have? 4. Now this number, I underlined the last sig fig. Only count up to the underlined number. 1, 2, 3, 4. That also has 4. Yes, the 2 is there, but it's not a significant figure because we would round it off based on the rules for subtracting. Okay? So 4 and 4, that means that this should have 4 sig figs. So 1, 2, 8, and 7. This is the 4th sig fig. That's in the ones place, so I don't have to worry about changing the value of the number. When I round, I look at the 6. That tells me I need to round up. And so I say 1, 2, 8, 8. 4 sig figs. Any questions? Multiplying and subtracting use different rules because error gets propagated differently. And so we have to look at each of them individually. So let's do this next one. 4.58 divided by 1.239. Press the equals button, see what it gives you, write it down. 3.69, this is giving me a whole mess. Let's think about this. This is dividing, right? Am I counting sig figs or decimal places? Sig figs. How many sig figs would this result have? 3. So I'm going to keep 3. I don't want to round it, though. Write down the next 2. You can write down all of them, but if you do 2, that'll be enough to avoid rounding errors. So 6, 9, and the next digits are 6 and 5. So I want to keep those so that I don't have a rounding error. Minus 0.578. So 3.6965 minus 0.578, and the result here is 3.1185. I took this number and subtracted that number. This is subtracting. I look at decimal places. This number, I underlined the last significant figure, 2 decimal places. This one has 3. So my answer should have 2 decimal places. And so I'm going to round that to 3.12. Any questions? If this is not making sense to you, please ask me to explain it to you again. I have lots of different ways I can explain it, but I don't have enough class time to just do it all, okay?